objects, right? One of the biggest things, one of my favorite analogies for learning to program, you'll hear a lot of people compare it to learning a foreign language, right? And I feel like programming goes a step beyond that. I feel it's more like trying to give basic instructions to somebody that's from another planet. If an alien came down here from another planet, it would not get any of your social references, won't have even a concept of your vocabulary. Everything that you could tell it to do would involve probably something that he or she has never seen before. So you would have to define every single term in detail. So I'll give you an example. Let's say if you have your alien friend, your new alien friend, if you tell him to go get some milk from the refrigerator, you'd first have to explain what a jug is, what milk is, what it does, what you do with it. So it's this concept, right? This single concept, a jug of milk, and it has all these properties to it, right? And all these things that it can do, all these behaviors that it engages in. Then you'd have to tell it what a refrigerator is. And there's a whole nother set of things, right? These can be very difficult, and that's why AI is such a hot topic right now, right? Because that's basically what we're doing. We're taking a computer that has no frame of reference for what we do in our daily lives, and the most basic things require something like 45 million different instruction sets, okay? So the way this starts, the way we handle this, the way we encapsulate all this information is through the use of object. Now, the analogy that I can use for what an object is it's the potential, it's all the building blocks for a potential object. So I would say it's more like having a set of blueprints and all the parts you need to build something. So if I take, for instance, a clock, right? Can I take all the parts that I would use to build the clock plus a set of blueprints to build the clock and then be able to tell the time? Can't look at that stuff and tell time, right? I would have to take it and then build the clock, and then I can tell time, right? And that's what classes are. Okay, so this user class that I've just created, public class user. Public is the access type, and it is a class called user, and it is not itself an object, but it's the potential for an object with all the stuff that I'm about to give it. First thing I give it is what's called a constructor. So I would say public user. What's a distinct feature of this constructor that I just made versus a regular method? Yes.
No return type.
No return type. And why would Java immediately look at that and say, oh, that's a constructor, so it doesn't need a return type? Why is that? Why will Java immediately recognize that as a constructor? Has the same name as the class. So Java looks at that and it says, hey, I don't need a return type there because that's a constructor. All right. So my job here is to create what's called fields. Another word you're going to hear for those is instance variables. Every time you create an object, basically what it means is it's an inherent part of that object. You don't have this object without these properties, right? So what would be a key characteristic if you were building a website that had controlled access? What would be a key characteristic of a user? Username and password, right? Okay, so what we want to control access, so we keep our data types private. So all of our data is going to be private so we can control how it's accessed, modified, and used elsewhere. So private, username would be a string, right? Password, private, hopefully string. What else would I need that would probably be, what would be the key identifying characteristic of a user object? Do you guys, if you guys have student accounts, ID numbers, right? Private. Let's make sure that's an int user ID. Okay. Oops. Man, I can't win. All right. So next thing I do is I set up what's called the default constructor. Default constructor does not contain parameters. The job of the default constructor is to take a look at all this stuff and say, hey, in case something else fails on the outside. So if you're writing a larger program than the things that we're writing, a lot of times user inputs would fail, right? Or other things, other parts of the software, especially if you're using anything web-based, some of those things can drop data packets, get errors, anything. So the job of my default constructor is to just simply set up these variables with some reasonable data values, right? Something reasonable. If I have a string for a username, reasonable data value for a default would be that, an empty string. It's the text equivalent of 0. Password, same thing. Password equals string. User ID is going to be a little bit different, right? User ID, am I going to need data for the user ID from the outside? Not in this case, and the reality is maybe, because I might have a program elsewhere that has this complex algorithm that generates a random user ID and I return it from that. But for our intents and purposes in here, we are going to use math.random. Let's just go from 1000, or let's just go 9999, right? And we want to lock it to somewhere there, right? Or actually, we're doing times, right? And we want to lock it to 4 digits. So I do something like that. I'll cast this to int, so we get a nice integer output. And I'll add 1,000 to it to try my best to log it to 4 digits. That'll have some little quirks to it, but in a basic sense, most of the time we're going to get a 4-digit number there. So I think we're good. So we have our username and password, randomly generated user ID. Okay. What happens if we want to actually set data on our user inputs? Well, if we want to do that as we're creating the user account or the user object, we are going to add some, we're going to overload the default constructor with a regular constructor that has parameter inputs. And those inputs are going to be a string for the username and a string for the password. Everybody good so far? Questions? Okay, so we start with these user inputs. Okay, I'm going to do all this same stuff, right? But here, I'm going to set this equal to the input UN and this to the input PW. Okay, so this would be hopefully like user inputs or something from the outside. My field user in gets set to that data value. My field pass W gets set to that data value, right? Whatever I'm inputting for that. And I'm going to generate this random number again. And a lot of you guys are thinking to yourselves right now, well, we already did that, didn't we? Here's why we have to do it again. it's the same reason that I can get away with calling both of these constructors user. I can give these both the same names. And this actually works for methods as well, but for regular methods, this overloading process, but it works a little bit differently, and we'll go over that at a later time. Right now, just remember that you can overload constructors, and the reason that they have, that we're able to get away with having them be the same name is because eventually, eventually I'd be doing something like this. So I create a new user, right, A, and I don't give it any data, right? But then I can create another user, B, right? And I can give it data. What Java is going to do is it's going to decide at runtime which constructor it's going to use. So at runtime, if I do this, at runtime, Java is going to go, hey, I don't have any parameter data. Totally going to use that one, right? At runtime, if I do this, Java is going to go, I got parameter data here. Looks like I'm using this. Does that make sense? I could even write a third constructor. I could write multiple constructors with the same name and go string UN, string password, and I can add another one for email, right? I'm not going to do that right now, but I could do that. I could have a billion constructors if I wanted to with all the same name, based on as long as the parameters have to be different. Again, if you're going to create a whole thing, you should have a purpose for doing that, right? So as long as these parameters are different for whatever reason, you can have multiple constructors for different purposes, okay? Java will decide at runtime which one to use. So just remember, if there's any common data, that has to be copied over to every one of your constructors, except in certain cases. And again, that's another thing that we'll go over at a later time. Everybody with me so far? All right. Anybody shaky? Okay. Now, I mean, on the details of this, not from drugs or other nefarious purposes. All right. So we're using here. So let's make sure all this works. Public class user. I'm running in Python because that's what I do in the previous class. So let's cannot find symbol in. Oh yeah, I didn't do any of this stuff yet. All right, so we're not printing yet. So now that we have all this data set up, let's go ahead and what we want to do next, okay? And the big thing, this is a key part of why we're even doing Java in the first place, why we're setting up objects this way, why the language is designed this way, is something called encapsulation. What I'm going to do with this data once it's set up is I'm going to control access to it, right? That's why we call these private, because I'm going to control the way that these get accessed, modified, and used. First thing we're going to set up is a modifier. What if I create this object and later I want to change my username? Well, I should have the ability to do that, right? So I need public. I'm using void now because this is a regular method, okay? It is a modifier, but it is a regular method, so I need access type, return type, right? Public void, and let's call it set values. Now, for a username, you might want multiple modifiers for this, right? For each one of these things. You know, public void set username, public void set password, that kind of thing. You might want to break them up. For my purposes in this one, I'm just going to do one for everything right now, so I know what I'm doing. So I'm going to set values, and essentially set values. Essentially, your modifiers do the exact same thing as the constructor. The big difference is we use these to modify the data once the object's already been created. Does that make sense? The job of these constructors is done once this user A or this user B gets created. So these constructors aren't actually part of the finished object, right? They disappear from the object as soon as they're done creating the object. So if I want to modify this data, I have to go back and use the modifier to do that. Now there's something I would say needs to be conspicuously missing from my modifier. You guys know what that is? What's missing from the modifier? What am I not modifying that I had in the constructor? User ID. Are you going to want your users to be able to change their permanent ID? No. Can you go into your user account and change your permanent ID? No, you cannot, right? Some of you would like to do that. There's some things on that permanent record we'd like to get rid of, right? So this is how we control access, right? We make it private, and then we say, oh, well, you can do this, but not that. This private gives you the ability to go, this can be done, but this cannot from the outside, okay? Then, so we can control what we're able to change, right? We can also control what we can retrieve and use somewhere else. Just so you know, if you're going to write a modifier, right, and you're going to go and you're going to work in this industry or have somebody look over your code at all, like if you get a tutor or something, modifiers usually start with prefix set. Always use set as a prefix for your modifier. It just helps everybody figure out what is what, right? If I see the word set as a prefix, I know, hey, that's going to be a modifier in a class. Just like set, if I'm creating an accessor method that's going to allow me to retrieve data, I'm going to call it get user, right? And I can return username. I can, return type, right? Yeah. We've done this before. We've used one of these methods before, right? Everybody's had trouble logging into a website and said to themselves, I forgot my password. Guess what happens when that system automatically emails you back your username and password? Dear blank, previously constructed return message object. Dear blank, your username is get username. Your password is get password. Eli. Why is it not static? So that's a good question. I think we covered it in the beginning, but it bears repeating, right? We use static a bunch in the beginning because did we go over objects in the beginning? Did we create objects in the beginning of class? When we first started in Java, we didn't want to create objects or bother ourselves with the concept of an object. So what we did was make everything static. Static means that that whatever it is that you're writing there exists independently of an object. So whenever you write static, that's why all main methods are static, because it's saying this is my entry point into the software. I don't want to have to create an object in order to run this. This exists independent of the object. Make sense? That's the difference between regular and static methods, variables, everything else. Okay? So here, I'm going to return. Now, maybe we want to return user ID. Maybe we don't want anybody to see the ID. That's up to the programmer, right? So we can control access to all this data just by leaving it in or out of our modifiers and accessor, right? I can say you can't change your user ID, simply by leaving it out of the modifier and the user doesn't have access to it, right? The other thing I can do is if I wanted to say, hey, you can't see your user ID, only I can see it, and I can just not include it in my list of accessors, right? The other thing I can do is if I want to control these in greater detail, I can set up something that says, oh, if you're logged in as admin, I can set a whole complex algorithm in here that says, if the user's logged in as admin, you can change this, but not that. That can all happen inside of your modifiers. So the depth with which we can control access to these is pretty infinite. But none of it exists without the concept of an object. This is why the world has switched to an object-oriented structure. And this would be the major difference between a scripted language like Python that some of you have used before and Java or a C language, is that this kind of encapsulation is an inherent part of the language. So in real terms, if I create user A with no data, and I go ahead and print that stuff out. I think I got all this stuff. Get password, get user. Some of this I used before. So it looks a little different. Let's run this and see what happens. I screwed something up. Return. I didn't want to return PW. I wanted to return pass W. Let's try again. Get user ID. User ID would be capitalized.
Yeah, it just says get ID, not get user.
Is it get ID? All right, let's do that. Get ID. Try again. All right, here we go. So no data except for randomly generated username, right? But if I create another user, I can give it this data, right? And that's what gets printed out for my username and password and stuff, right? Let's go. So that is using array. This is using default, and that's using a regular constructor. Now, if I look at my user object A and I say, you know what? I really want to set some data on there, right? I actually want to give that some data. I can then go in here and I can say, hey, set my username and password to that. And then I can reprint it. So if you look, I can copy and paste this verbatim. This is the same stuff, right? I can copy it here. And if I run this,
you need to get rid of the user modifier.
Which one?
It says
Oh yeah, I accidentally, there we go. Accidentally decommented that. So if you look, these two are the exact same objects printing the same stuff. The difference being in between here and here, I've set the data to this stuff. Questions so far? Okay, really for most of Lab 7, if you have a good command of this, everything else is easy. Super easy to do anything I'm going to ask you to do. There's definitely going to be more labs that we're going to set up where things are going to get a little bit more complicated, but we are now done with new concepts. Okay? Everything else is just building off of what we know about objects now. Make sense? All right. That's